Okay, so we are back. Sorry for the disruption. And then, so we just run the map. We don't need to return a list from this or something. We just run the map once. We get all the values in our map, correct maps. And then we run it with tmap as well. And at the end, what we can do is simply compare smap with tmap, because both of these maps are now correctly updated using the map function. Let's try printing these once. So can we print smap, and then can we print tmap? Okay, so we have to use list. And it works correctly. So one thing I want to know now is, why do we need list? Why? Okay, so list forces the map object to execute. As we have seen before, Grok is very detailed, so it gives us a very detailed explanation. We don't need to look for explanation somewhere else. We have our detailed explanation here. So list forces the map object to execute as map is lazy. In Python 3, the dictionary is updated in place. So list basically forces this whole map function to execute as soon as we reach this point. So this is working. Let's try submitting this once. This is a bit slower. And what if we don't use this and we directly use the lambda functions? So it will be list, then a map, a lambda function, x of, then we will just write our smap of x plus equals to 1. And then we will run this for s. Similarly, we will write the same thing for t. We will take this and change it to t. Again, this should give us the same result. Let's try running it once. Lambda, where did we mess up? Okay, we have to do frequency.update and this thing. We can't just directly go. Okay, for this key, we are setting the value to this. Let's do this. And also we will ask why do we need this? In this code, why do we need to write frequency dot update? Why can't we directly perform an operation? Like frequency x plus equals to 1. Is it, maybe it's because x doesn't exist in the beginning? So is it because x might not exist initially in the default deck? But that's the whole point of us creating a default deck, that we don't have to worry about that. In the meantime, we can update the code to the correct syntax. It will be smap.update So we are updating the key x to the value of s map, whatever we have, for x plus 1. And similarly, for t map, we will also do the same thing. We will update it to x key will now be t map, and then the value of x plus 1 for all of the values. Instead of directly, this is because x might not exist. Let's break it down. Why this? Why not that? Uh, in the map function is not strictly necessary in this because we are using which automatically initialize. Uh, to work fine with default deck. The reason was used in original code stylistic choice. Uh, since frequency is accessing return 0, it also increments to this. So we can also set like set item to this, but can't we directly write this? So we do need to like say explicitly that this is what we need to set the item to. This item should be set to this. We cannot write the direct syntax like this. So we will have to use update. Let's see what's giving an issue. Invalid syntax. How, where, why. I think it's the approach that we already have figured out, that just use create a function and then use it, works better right now. So let's just stick to that. We already have a solution for this question, so let's not waste some time, more time on testing random iterations. We can just move on to the next solution for now. Next question for now. Let's also go through the solutions and see if there are any new, more unique and novel approaches taken by other people. The first solution is simple counter. It creates a map. This creates a map. You compare them and you get the result true or false. This is a simple check that both should be the same. And then if they are not the same, then it should be automatically be false. Then we will create a manually. We will count each of those numbers and then we will check if they are the same or not, or we can do just -1 to check if all of them are the same. So this removes the need of double creating two maps. We will just be done using a single map. So if we wanted to save the space of creating another dictionary, we can just use the single dictionary. First, we update it by adding one element. Then we remove one element one by one. And if at any point it goes to 0, we just return false and say that, okay, there are not enough characters in one string to complete the other string. And similarly, we can do this using a character array as well by using ASCII operations where a minus a is equals to 0 and z minus a is equal to 25. So that's another solution. We do space complexity of constant. So this becomes constant, and the third solution is just more complex stuff that we don't need to get into. So let's move on to the second question in the list of the medium category. Given an array of strings, group the anagrams together. You can return the answer in any order. So we have a list of strings and we have to group. each of the anagrams. So one of the ways I can think of doing it is in our dictionary, we will have to maintain a dictionary where we will have first some unique identifier of like what all characters are in this particular string. So for whenever we see our first string, we will create this unique key based on all the characters that are in that, and then we will add to that list whatever other strings that we see that have the same exact characters. And if we see another string that does not match any existing strings, any existing keys, then we will create a new key and a new list for that. One of the ways of creating this unique key that I can think of is we can either, this can be some sort of complex thing, maybe a number string that this many characters are there, 0, blah, 0, 2, and dash, 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 dash. One problem with that is if you have 22 and then 2 or 2 and 2, that gives you an issue. So that will also result in a very long string. Another thing that we can do, let's see how many characters we have in each of those strings. So the string's length can go to 10 to the power 4. So we can have 10,000 character, I guess, yeah, approximately like 10,000 characters. So first I was thinking that this approach is the first one that we count things. How many A's are there? You can say 1A, 0B, 2, and we create a string like this. Another way would be to go, there is 1A, then there are C, so we sort this so that they are all the same. Another way I can think of now is we can say A1 and then C2. So this way, we don't need to waste space on zeros and we don't need to like spend this much space of 10 to the power 4 on the string. We can compress it like how many A's are there, how many D's are there. So we can create, and to achieve this, we can do it in two steps. First, we will create a character array that will count these things. So 1, 0, 2, blah, blah, blah. Basically, we will use a counter to create this. And then we will iterate over this whole array. And then we will create this dictionary sort of string that will be our unique identifier. We know there are only 26 characters. All of these are lowercase English letters. So we will have only 26 of these. And then these numbers can't go over 10,000. Even if we have like 10,000, then it doesn't go that long. So this string stays in limit. And we uh, don't have to worry too much about our key being too long. So I guess this approach can work. Let's try this. So for each of the strings, so for each of the words in strings, let's create a character array, which will be 0 into 26. And then for, we can also create a dictionary because, yeah, we can just simply create a dictionary and then convert it into a string. One problem with that might be that it will not be sorted A to A, B, C, D. So if it becomes C2 and A1, when we perform a hash, this will be different than this and we want it to be sorted. So let's just stick to character array for now, which will be 0 into 26, one for each character. And for each character in the word, so for word in strings and for character in word, we will do character array. We will get the ordinal value of the character minus the ordinal value of A. This will give us the exact index 0 to 25 that we need. And then we will do just +1 to increase the counter. And then for I in range 0 to 26. So we will just go 26. We will iterate over the character array, and this will be our unique string. So basically, this is our unique identifier that we will store in a dictionary, and this will be our result dict. This is a dictionary. This will store a string, comma, list pairs. And at the end, we will just return a list of lists. So all of these lists, we will put it in a single list and send it over. And this is initially empty. And for each of the strings, we have at least one character, so we don't have to worry about that edge case. And for each of these, let's move over the character array. If character array at location I is a thing, then you get a unique string to be. So what are we adding? We have to figure out like what is the value at this location. So we have to get the opposite of ordinal. Let's ask Grok, what is the opposite of the ordinal function in Python? I want to get the character from the ASCII number. Is CHR, so we get the character using CHR of I. So I plus ordinal value of A. So this will give us like I plus 0, I plus something something. And then we will get the character, and then we will add the character array value, this whole thing, as a string into that. So this will be our current string, and then just add the current string to the unique string. Right, so at this point, when we get out of here, we will have a unique string that will be same for all anagrams. The unique string will be same for all anagrams. And now we can check result dict of unique string. So we have to check if unique string in result dict. Then we will append we have to carefully append the word and not the whole unique string, because unique string is just the identifier. It will be the same for all the anagrams, but the actual anagrams will be different. So else we create one. We create a list of list. Sorry, a list of words. So we just put it here. And then at this point, we should have our result decks populated with the group of lists. At this point, what we have to do is just get the result as in a list. For that, we will do key and then value for result dict dot items. And here we will add in our result dot append value, and then we can just return the result. So ideally, if I have not made any silly errors, this should work. Okay. Uh, yep. Silly errors like this. Awesome. This works. We are getting the string list of strings. Let's try submitting this once. And it got accepted. So our solution is technically correct. It is a little slow. So we will now experiment with it to make it better. Uh, so here we are currently using a lot of loops, lot of conditions, lot of string operations and stuff like that. Maybe we can simplify that a little bit and that can help us. So another way to do this would be we still need a dict so that we can maintain a mapping between the unique identifier and the list. And maybe we can simplify this into a list like a value for key value and result index dot items, and hopefully this should get us the same result. Yep. I guess another way we can try doing this is result can be just the list of result dot values. If I'm correct, there's such thing, then it should work. Yep, we can just directly say that give me the list of values. And we can also remove this part. So we can simplify this just in a single line that return the list of dictionary values. Now let's see if we can simplify this logic a bit more. So currently what we're doing is we're iterating over all of the words. Then we are creating a character array. Maybe we can do this using a dictionary as well. So currently we are counting one by one. Let's try doing this using the counter. So from collections, import counter, and then we will have our character array, which will be just counter and then word. This will give us a map. So character count would be a better variable name for this. We have a map from characters to their counts. Now we need to see if we can get a unique string. So can we sort a dictionary? That's the main question. Can we sort a dictionary and then iterate over it sequentially in Python? Yes, we can do that. But since dictionaries are inherently unordered, prior or insertion ordered, sorting typically involves sorting the dictionary's keys, values, or key value pairs, and then iterating over the sorted results. So let's try doing that. Sorted, and then we get the item sorted. Let's try that. Sorted items. Let's sorted. Character count dot items. So this will give us sorted items, and then we can comment this part out. We can iterate for a key and value and sorted items. And then we just have to do a unique string plus is equals to, we already have our key as a string. So we can just do key plus value. This should ideally give us the same thing that we were doing using this a little bit more complex code. Yes, it did, and that worked. And similarly, we can try to simplify this part. We can do result direct, and then we can get the we can do result direct of the unique string. We can get the list from the unique string, or we can get an empty and then dot append. Let's see if how this works, or even if it works or not. Comment this out, try running it once. Yeah, I just made this up, so this doesn't work. Let's try. If I have a dictionary of lists, so basically a string as value and then a string as key and list as value, then can I do something like this? Instead of writing the whole thing? If not, then what's a simpler way to save this if is check? We cannot use that because it will not work. List.append modifies the list in place but returns none. Okay, got it. So as a result, this would be set to none. What we can do is result dict set default unique string to this and then this whole thing. So set default method is a clean way to get a default value in an empty list in this case and then modify it. So we can just say that I want the value of this and I want to append this to that. But if it doesn't exist, give me an empty list. And then for that key, I want this. So that's a good approach. Thank you, Grok. And so result direct.set default unique string, and then we set it to empty list, and then we append the word. Let's try running this once. This works correctly. Great. Now let's try submitting intervals. So we have compressed our code into like 1, 2, 3, 4, 5, 6, 7, 8, 9 lines essentially from what it was before. And if you try hard enough, you can go even smaller, but we are not going to push it too far. We are just going to now see what other people have done to reduce their time complexity and solve this problem much, much faster. So one thing that I like about Grok is that you can provide it with your queries. Like this is the wrong solution that I was trying to replace this a little bit more longer code. And I was wondering if this can work or not. And if not, just give me a simpler way to check. A simpler way. Okay, so yeah, just a simpler way to like solve this whole thing. And Grok did that and it was great. So now that we have solved this question, let's try to look at the solutions and see where we can improve. Provides good solutions. So let's go with this person's solutions. They have the same thing. Simply, if we can sort the character of each string, we can group them. That was the same idea that we were getting a unique string for each of the strings, which was a sorted thing. So the reason why I didn't go with the sorted approach is because if the string is very long, then you need that long of a key. But this approach of using key and like characters and numbers allows us to compress that even further into just 26 keys and their values, which can work if you have a very, very long string. Now your hash function hopefully gets like a little bit of a boost because your strings are so small. So for each of the strings, they joined sorted. So basically they sorted this and then they just appended that, which was the easier solution. Let's see if they go to, yeah. So the basic idea of solution 2 is the same, but the difference is that we don't have to sort each character. First of all, they went to the same approach as we did, that we created array with 26 length. 26 is the number of alphabets. After that, we use ASCII values. So ASCII value of A is 97 and this and this and this. So they have this whole thing. If you want to access this, the same thing. And now they did a tuple. So they stored this whole thing as a tuple. We did it as a string. We can also do it as a tuple now. So basically we have the same character array. We can try using the whole character array as a tuple. So then we will have a simple count of 26 things. So it will be 1, 0, 2, and then so on and so forth. That will allow us to skip this part where we are creating a string. Let's try doing that once. So let's comment this whole thing out as our first approach and second approach. So approaches 1 and 2. And then we can just comment this whole thing out. Let's try creating another one. So we will have our result dictionary. That will be a dictionary. And then for each of the words in strings, let's remove this part. We don't need to keep looking at the solution. We will create a character count. And that will be 0 into 26. And for each of the characters in the word, we will go and update the character count array for the ordinal value of the character minus the ordinal value of A, which will give us 0 to 25. And we will just add 1. And then when we want to store the word, we will just go result dict, uh, convert this into a tuple because tuples are immutable. So let's see, why can we use tuples as keys in a dictionary and not lists? So because tuples are immutable, they are hashable. Okay. And that allows them to be used as keys. Similarly, with like we did with strings. So we can just use a tuple based on the character count, and then uh, again we can either do check that if this exists or not, or we can do uh, the set default. So result dict dot set default of the tuple at character count at this key. Either if it exists, give me a list, otherwise give me an empty list, and we will just append our word in this, and then we will just return the list of all the values, the result dict dot values. And this allows us to skip the part where we were converting things into a string for storing it in the dictionary, and speeds up the process up a little bit as well. Let's see what's another famous solution. So they are just sorting things. So this approach I don't like because uh, of we have to sort a very keep a very big key. So that's why I don't like this approach of directly sorting S and storing that. But that works faster. You don't need to create an extra word count and stuff. Let's also just try that approach. This will be approach 3. This was our approach 3. Now we can just move on to approach 4. So in this time, we will just say, let's create a dictionary. And then for each of the words, word and strings, we will create a key, which will be the sorted S. And I guess this will return us a, let's actually print what this returns. So what is our key right now? We will just return an empty list for now. Sorry, word. So we get a list with A, E, and T, which is basically our sorted characters. We can convert this into a tuple, and then we can use it in our result dictionary as a key. And like we did before, we can just say set default of this key, or give me a empty list, and then just append the word, and then give me the list of values as a result. So this also saves us from performing the character counts. It works on the test cases. Let's try submitting it once. It works, and it works faster. It takes up, I guess, a bit more memory, but not that much because the size is still relatively very small. So this approach saves us for the time. And if we really want to push things and go really Pythonic, let's try doing this in like one line. Just for the fun of it, because Python allows us to do this. So we will just do return, and we will create a list of a dictionary. I think we will need 2 lines at least. So, but let's see how far we can push it. So for word in strings, I know that we can do uh, word, sorry, we will say, how can we do this in one line? And let's just ask Grok, how can I do this all in just a single line? Yep. It even imported this thing in a single line. So this is the correct one-liner that Grok provided us. Let's see how it works and then we'll see. Oh, it's so long. Uh, we have to import the default dict for this. So let's just import it up here. And then we are creating a list. That's what we have to return. Default dict of list. We are updating it with the tuple of sorted word uh, with the list of word for word and strings, or so I guess this whole thing will run first and then this thing will run. Oh my god, how is this even possible? And if this works, it's a miracle. It doesn't work. Okay. I had high hopes, but okay. It is like a good solution that we got at the end. We have a result dictionary and let's just uncomment this. Yep. So we got a good solution at the end and we can mark this as completed. And I guess I will be just be solving these two questions today. I had the goal of three. I had some issues, but that's okay. We tried a lot of different approaches and that's great. Now I just want to quickly mention that Grok is my favorite platform for coding because you can just give it as a problem that you are trying to solve and ask that if there is a way to solve this in any improved manner and to see if my solution works and how it works. Grok provides you with like a very detailed explanation of everything so that you don't have to ask it a follow-up question of, oh, you missed this or that. It just works in the first go. So that's why like I prefer Grok and that it has been great. You should try it too. Thank you. That was all for today. Thank you for joining. Thank you for everyone who